So we have another example here where we have the given. So let matrix A equals, you have the components or elements 1, negative 4, negative 1, 1. Okay? So we're going to find the eigenvalues of A. So in defining eigenvalues of A, we will begin with the equation Ax equals lambda x. Okay? Where we have A now is the given matrix where we have the components 1, negative 4, negative 1, 1. Then multiplied by vector x where we have the elements of vector x as x1 and x2. Why is it x1 and x2? Because there are only 2 rows here. So each row represents vector components. So x1. For the second row, it is x2. Okay? Then we have now lambda. Then x again will be x1 and x2. Okay? So what we're going to do is to perform now matrix operation on our equation, right side, specifically on the left side rather, of the equation. So we have 1x1 plus negative 4x, so that is also minus 4x2 is equal to lambda x1. Okay? So let us call this as equation A. And then the second equation will be the second row multiplied by the column here. We have negative x1 plus x2 is equal to lambda x2. Let us call this as equation B. Then arrange now your two equations in such a way that similar terms can be combined here. So let us have first the lambda written first. So okay, on the left side of the equation, so this is now negative lambda x1 plus x1, then minus 4x2 equals 0. Then we have negative x1, so negative, the x1 should be written first before the x2, okay? Then plus, you have, or minus lambda x2 plus x2 equals 0. So we should write first lambda again before the other coefficient, which is 1 for x2, okay? Then from here, let us now form the matrix, and this refers to as the coefficients of x1 and x2 in the given two equations. So we have negative lambda for the first row. Then for the second row, we have with us, it should be negative 1 plus, negative lambda plus 1, okay? What about for the second element here, negative 4? Then for the third, or I should say for the second row, we have here negative 1 as a coefficient of x1. What about for x2? Negative lambda, then plus 1, okay? Then equated to 0. Then from here, the final determinants of this matrix. Okay, so finding the determinants of this matrix form. So we can now have with us, okay, the product of the diagonal elements of the given 2 by 2 matrix. So we have negative lambda plus 1 multiplied by negative lambda plus 1. Then minus negative 1 times negative 4 will give you positive 4. Okay? Equals 0. Then from here, we can now expand. So multiply the two binomials here. This is now lambda squared. Then you have negative lambda, and then minus negative lambda also. That is negative 2 lambda, then plus 1 minus 4 equals 0. Then you have now lambda squared minus 2 lambda minus 3 equals 0. Then get now the factors. We have lambda minus 3 and lambda plus 1 equals 0. So what are the values of lambda? 3 and negative 1. So these are now the eigenvalues of the given matrix. Okay? We can now get the eigenvector corresponding to each eigenvalue in our previous problem. Okay? So find out the eigenvector associated with each eigenvalue in our previous example, which is in our problem A. Okay? So the two eigenvalues that we have determined, let us call this as lambda 1, and lambda 1 is equal to 3, and then lambda 2 is now negative 1. Okay? Then let us have the matrix again, given us, here with us, 1, negative 4, negative 1, 1. Okay? So, we have the equation a while ago that we have negative 2 lambda, or I should say negative 2x1 plus, sorry anak ha, cut mo na, Richard.